Hello everyone, so today's live session is based on P2 proof. So in this new specification of P2, we have around 4 kinds of proof: proof by exhaustion, proof by deduction, proof by contradiction, and proof by counterexample, right? And so far I have already posted 3 different videos from this 4 proof. But since we have very few limited selected papers of P2, it's just that we have past papers of 2019, 20, 21, and 22. So it's just a 4 years, right? 4 different years. So I will be solving all the proof related problems from the past papers, and along with that, we will also discuss the problem from the sample assessment paper provided by the Deduction. So So let's get started. We will just start from June 2019, P2. So all the proof related problem from the P2 past papers and the P2 sample assessment paper will be covered in this live session. So these are the 3 videos I have already posted on my channel. So that's the proof by contradiction, and these are the 2 previous videos that explains the basic problems, basic concept of this proof thing. So you need to solve all the example problems I have discussed here. I have even included 3 or 4 practice problem in this proof by contradiction video. Okay, so we will be starting with June 2019. So this is June 2019, P2 June 19. Number 3 is from this chapter, proof. Okay, so then again, even though there are questions that are directly related to exhaustion, deduction, contradiction, but you will also get questions like this where they will give you inequality as in greater than sign or less than sign. And you will see that in majority of the cases, you just need to work with the completing square format. So let me start with this one, number 3 of June 19, P2. So we have this equation. We need to prove this statement. So at first, I will just start with simplifying this line. So at the left side, we need to expand this using a minus b whole square formula. I guess you know this one. A minus b whole square is a square minus 2ab plus b square, right? So 4 square minus 2 into a into b. Then we have 4 as the b. So x square minus 8x plus 16. If I shift everything at the left side, we will have a 0 at the right side. Eventually, this is the final quadratic equation. This is the final quadratic equation. So like I said, we need to work with the completing square thing. Whenever you have something greater than 0, it means you can express this thing. At the left side, you try to express that as a whole square thing. Because if we need to prove something positive, greater than 0 means we are dealing with positive, right? So if you have a square number, it's definitely going to be a positive thing, right? So for inequality greater, you need to express that in the format a minus b whole square or a plus b whole square thing. So if I just rearrange them, according to this formula, we will get a square 2a b, you can just write as 5 2s are 10 plus 5 square is 25. So it's just that this line can be expressed like this. So if we compare this thing with our formula, It's basically a minus b whole square formula, right? So x minus 5 whole square. And we are done. This one is a little bit easier because as you can see, we didn't even have to balance the b on the in this equation. It was already given. The entire thing was already given. But then again, if you need to learn the completing square thing, where you need to adjust the plus minus thing so that you get a specific b, so you can check out the other video based on completing square, which is available on my P2 playlist. Okay, so we started from here, then we expressed this in terms of a completing square thing. And now we can just write that since it's a square number, any square number is always greater than or equal to 0. So we are done with 3.1. Next, we have 3.2, where we need to prove 2 to the power n plus 1 is a prime number for all values of this. Okay, so show that this statement is untrue, as in we are trying to disprove this equation statement, right? We need to disprove it, as in you need to prove that this statement is not true. The statement is false. That's what we are trying to do. So 2 to the power n plus 1 is a prime number. So you need to use any value of n that will actually disprove this statement. So you can, it's just a trial and error method. You can start with n equals to 1, n equals to 2, n equals to 3. So if I select n equals to 2, it's going to give us 5, which is a prime number. So that's not going to work. So let's try with n equals to 3. 2 cubed plus 1 equals to 9. This is not a prime number. 9 is not a prime number. So this actually disproved their statement. 2 to the power n is a prime number for all values of n. But we just actually used a value n equals to 3 that doesn't give us a prime number as a result. So this kind of trial and error method, you can directly use the final step, or you can even include the steps related to the before getting the actual value. You can even show the steps of the trial. Okay, so this is number 3 from P2 June 19. We are done with this one. So you can take a screenshot of this. I will be moving on to the next year, which is Jan 21. In Jan 20, there wasn't any specific question related to proof. So I will be moving on to Jan 21 P2. So this one is also related to inequality. So let me start. 5.1. So this is the equation. I will be writing this. At first, I will write this one. Since you have a square root at the right side, you need to actually simplify it, right? So I can take square on both sides of the equation so that I can get rid of this square thing, square root thing. So I will be using square on both sides of the equation. So at the left side, we have to express it in terms of the a plus b whole square formula. You need to expand that. So a square 2ab plus b square. And at the right side, if you just square them, 2 square is 4. And this root will be canceled out. So we are left with 3x only. So that's 9x square, 6x plus 1. And then if I shift, this is actually 12x. When you shift this thing at the left side, the sign will be changed. It's minus 12x rather than 0. So the final quadratic equation here is actually 9x square minus 6x plus 1. So next we need to express this in terms of a completing square. But then again, if we can express it using the formula a square 2ab b square. Like I said, we do not even have to adjust anything. It's a square 2ab b square. It's already given in the previous line, right? So I just rearrange this line in this format, a square 2ab b square, so that I can replace it with a minus b whole square. So the next line should be 3x minus 1 whole square. So since this is a square, whatever the value of x is, it will always be, it might be equal to 0, or it will be greater than 0, because we have a square sign. So even if we get anything negative inside the bracket, it's going to be converted into a positive value because we have a square over here, right? So yeah. So you can just write the same statement here, this line, square number is greater than or equal to 0. So you need to write that line here. Square number is always greater than 0, greater or equal to 0. So that's 5, 1. Next, 5, 2. So 5, 2, we need to prove that the sum of the 3 consecutive prime number is always a multiple of 3. We need to disprove the statement, right? So you can use any value that will actually prove the statement false. So what are the prime numbers? Suppose if I start with 3, 5, 3, 2, 3, 5, 7, 11. So I can continue like this, right? So I just need to select 3 consecutive prime numbers that the sum of which will not be a multiple of 5, right? We are trying to disprove the statement. So since it's a trial and error method, I can use the calculator. So we will get 2 plus 3 plus 5, that's 10, right? So 10 is a multiple of 5. So you cannot use this one. Okay, next, if I start from 3, 3, 5, 7, 3 plus 5 plus 7, that's actually 15, right? That's also a multiple of 5. So we cannot take this one. Next, if I use 5 plus 7 plus 11. 5 plus 7 plus 11. That's 23, which is not a multiple of 5. So you just need to show this working, that I'm selecting this 3 consecutive prime numbers. So sum of them is 5 plus 7 plus 11, which is 23. And 23 is not a prime, 23 is not a multiple of 5. Sorry, it's not a multiple of 5. But they actually mentioned that it's always going to be a multiple of 5, but we just proved them wrong. So that's what we had to do. This is kind of a counter example thing. So this is Jan 21 P2 number 5. Okay, so we are done with 2 problems. One from June 19, and the second one is from Jan 21. Next, I will continue with this year 21. So the next year should be May 21. This is May 21, number 3. May 21, number 3. In this one, prove that for all single digit prime numbers, p cube plus 3 is a multiple of 10. Okay, so they have already restricted the limit. We have to deal with the single digit prime numbers. So you cannot exceed 10. So it has to be less than 10. So these are the values of P. So if I just select the values of P, since we are selecting prime numbers, right? So we need to start from 2, 3, 5, and 7. Okay, so the next one is 11, then 13, but those are not single digit. So we have to deal with single digit prime numbers. So these are the only 4 options we have right now. So we need to calculate P cube plus 3, right? So P cube plus 3 should be, so this is 2 cube plus 2, then 3 cube plus 3, 5 cube plus 5, 7 cube plus 7. So I will just use the final results here. So this is 10, 30, 130, and 350. And all of them are a multiple of 10, right? All of these values are a multiple of 10. So that's what we had to prove. 3, 1 from P2 May 21. Again, next we have this equation n plus 1 whole cube minus n cube. It is not a multiple of 3. Okay, so for this portion of the equation, we need to use the formula a plus b whole cube. So a, just like we know the value for expansion of a plus b, a squared plus 2ab plus b squared. Similarly, you can remember the expansion of a plus b whole cube. That's a cube, 3a square b, 3ab square plus b cube, which is actually from the binomial expansion. So you can remember this formula. So now I will just start with our problem, n plus 1 whole cube minus n cube. So this first portion, I will just use the formula. So n cube, 3n square into b, b is 1. So I can just exclude that one. It's going to be the same result, right? A, 3n, 1 square. So that's 3n plus 1 cube, which is 1. Okay, so this is just the expansion of n plus 1 whole cube. And then you have n cube here. So this will be canceled out. You are left with 3n square, 3n plus 1. Minimum কতগুলো show করলেই হবে? In this case, since they have already mentioned we have to deal with single digit prime numbers, we only have 4 options. But if nothing is mentioned, it's always better to at least try from 0 to 10, values available from 0 to 10. Like I said, if they do not restrict the limit, you start from 1 to 10. 1 to 10. And within that range, you need to pick the values related to your question. But if you suppose we are dealing with multiple of 5, in that case, from 1 to 10, we have only 2 values. So it's better to at least show 4 or 5 values, just to be on the safe side. Okay, so the thing is, we have, if I just use this first 2 points, it's first 2 values, 3n, in that case, it's n plus 1, and then you have a plus 1. So this portion, wait, instead of 3n, you just select 3 from here. So it's just that 3 into something. So this first portion, it's a multiple of 3, and then you are adding 1 with that. So overall, this value will never be a multiple of 3. That's because multiple of 3 has to be, multiples of 3 have to be at a difference of 3, right? If I just look at the values, 3, 6, 9, 12, 15. As you can see, the differences are what? The difference is fixed, it's 3. If we are dealing with multiple of 3, the values will have a difference of 3, right? Similarly, if you are working with multiple of 4, 8, 12, 16, so the difference is 4. So that's it. If we are dealing with multiple of 3, you cannot expect that the next value will also be a multiple of 3. As in, this is 6. So if I add plus 1 with this, we will get 7. That's not a multiple of 3. If I add 9 plus 1, it's 10. That's not a multiple of 3. For a value to be a multiple of 3, we need to add plus 3 with that, right? So this portion, this first portion, it's a multiple of 3, and then you are adding plus 1 with it, right? Suppose 15 plus 1, this will give us the immediate next consecutive term, right? So if we're getting the next consecutive term, it's not going to be a multiple of 3, because the multiple of 3 should be at a difference of 3. The next one should be 18, right? So that's it. This value, which we got 3n squared plus 3n plus 1. This is 1 more than multiple of 3. So since it's 1 more than a multiple of 3, so this final value will never be a multiple of 3. So I will just remove this extra explanation thing. That's the final working for number 3, P2 May 21. Sorry, n squared plus 3. Sorry, n squared plus n. N squared plus n. So this part is a multiple of 3, and then you have a plus 1 with it. Thank you, Wasir. Okay, so I'm done with number 3. Let's move to October 21. Like I said, I'm covering all the problems of proof-related problems from the P2 past papers and sample assessment paper. So in October 21, we had this question, number 9, which is also based on inequality. We have this greater than or equal to sign here. So 9a. So I will just start by writing this equation: x plus y divided by 2 greater than or equal to this. Since you have a square sign here, square root, so to remove that, we will be taking square on both sides of the equation. So at the left side, you will get x plus y divided by 2 whole square, root xy whole square. So we have x plus y whole square divided by 2 square is 4. And at the right side, the root will be cancelled out. You are left with xy only. Now I will just use this formula, a square 2ab plus b square. And if I shift this 4, as in you are using cross multiplication, if I just shift it here, it's actually 4xy at the right side. So x squared 2xy, y squared, then the 4xy at the left side will give us minus 4xy greater than 0. Simplifying it will give us x squared 2 minus 4, that's minus 2. So even in this problem, we are not actually adjusting anything. It's already in the format a minus b whole square, right? So we do not need to do any extra effort here. A squared 2ab, b squared. So since this is a square number, any square number is greater than or equal to 0. As in, it can never be negative. It's always greater than 0. So that's 9a. That's 9a. Next, I will start with 9b. Prove by counter example that this inequality does not hold when x and y are both negative. So they are trying to say that you need to select negative values for both x and y. and then this inequality won't be valid anymore. So you have to prove it invalid. Okay, so I will start with this equation, and just like I said, it's a counterexample problem, so it's more like a trial and error thing. So you can select any values, any negative values here. So suppose I'm selecting 1 and 2, minus 1 and 2. Let x equals minus 1 and 2. Okay, minus 1 and minus 2. So if I select, instead of giving this greater than sign, you just replace the values of x and y. I'm selecting x equals minus 1 and y equals minus 2. So minus 1, minus 2. So minus 3 by 2, and minus minus will be plus, so it's root 2. So if we just look at the decimal values, just to be clear, it's 1.4 something, right? And at the left side, it's minus 1.5. Minus 1.5. So obviously this is greater, right? The right side of this equation is actually greater. So this is the situation, but according to the question, it was supposed to be greater or equal, right? But we just used negative values and that reversed this entire situation. Okay, so you just need to show this working where you substituted negative values for x and y. You can even use different values of x and y, minus 2, minus 5, minus 7, any negative values will work. So that's number 9 from P2 October 19. P2 October 19. Next, so this is P2 May 21, P2 October 21. Hello, Nabiha. Grade boundary completely depends on the question. Question tough আসলে তোর টেনশন নেই, tough আসলে তোমার by default grade boundary কমে যাবে. P1 was a bit lengthy as far as I have heard. P2 কি হয় দেখো. Okay, P2 Jan 22. Oh, we are at the last paper. That was fast. So I just covered 4 problems, and then this is the last problem. P2 Jan 22. P2 Jan 22. So prove by counter example that the statement this is not true. As in, you need to disprove the statement. You need to prove the statement is actually false. That's what we're trying to do. P is a prime number. So according to them, if P is a prime number, in that case, 2P plus 1 should also be a prime number, but that's what we are going to, that's what we will prove wrong. We will select one prime value for P that will not give us a prime number here. Okay, so let's start. Since it's a trial and error method, 2P plus 1, that's the value we are trying to find, right? So if I select P equals to 7, suppose P equals to 7. In that case, it's 2 into 7 plus 1, which is 15. This is not a prime number. Okay, this is not a prime number. If you select P equals to 10, it's 2 into 2P plus 1, right? It's 2 into 10 plus 1. This is also not a prime number. So you just need to prove, you just need to include any one example that actually disprove the entire situation. Next, use proof by exhaustion to prove that n is an integer. In that case, n squared plus n plus 12 is always even. So for exhaustion method, it's just that you need to prove almost each and every single case, but then again, they didn't, if you start like this, for different values of x, and you are actually calculating at 5n squared plus n plus 12. If they actually gave you a specific range of values for n, in that case, it's logical. But since they didn't mention any specific value, so, and we have to prove that for all values, integer values of n. So when we are talking about a generalized situation. You cannot actually use 2 or 3 numerical value and just say, okay, if this is the situation, we have used few values of n, and if it agrees, if it actually satisfies this equation, all the other values will also satisfy. That's not how it works. So for this type of situation, it's always better to use different variables, as in you can use n as odd, or you can use n as an even value, because that's the only two kind of numbers we are dealing with, right? Either n can be even or n can be odd. So we will be selecting two situations where n is even and then n is odd, and we will prove that for this both situation, this expression will always be even. And we know that for any even value, it has to be a multiple of 2, right? So suppose when n is even, assuming that n is even, in that case, n can be expressed as 2k. Anything as a multiple of 2 will be an even number, right? So I can express n as an even number, 2k. Oh, sorry, p was supposed to be a prime number. Sorry. This is wrong. Sorry. 10 is not a prime number, sorry. So p equals to 7 will give us this. You can even select 11. Let me check. With 11, it's going to give us 23, which is a prime number, but we had to disprove that, right? We do not need any extra value. We are already done with this one. We have to just prove one single example that will disprove this statement. So we are good with this one. So when n equals to 2k, then I will try to find 5n square plus n plus 12. That's 5 2k whole square, 2k plus 12. 4 square, 2 square 4, so that's 20k square, 2k plus 12. And since we need to prove this as even, I will just take 2 out of this equation. So this is actually, it's a multiple of 2. Right? It's a multiple of 2. So since this is a multiple of 2, this expression is actually even. Next, if I select n as an odd value, if n is odd, in that case, you just need to add plus 1 with this one, because 2, 4, 6, these are even numbers. If you add plus 1, you get 3. If you add plus 1, you get 5. So adding 1 with an even number will result in an odd value, right? So for odd, when n is odd, suppose n is odd, we will express it as 2k plus 1. So now 5n squared plus n plus 12. I will just substitute the value of n, this expression. So that's 2k plus 1 whole square, 2k plus 1 plus 12. So if I expand this using a plus b whole square formula, we will get 4k square, 4k plus 1. So that's a little bit lengthy. So we get 20k square, 20k plus 5, 2k plus 1 plus 12. So 20k square, 20 and 2, that's 22k, 5 plus 2, 5 plus 12. 5 plus 1 plus 12. That's 18. So next you will just take 2 out of it so that we can express it as a multiple of 2. So that's it. Okay, so this is also a multiple of 2, making it an even number. So that's even, that's even. So that's it. That's Jan 22. Jan 22, number 10. Okay, so we just solved all the proof related problem from the past papers. Last one is this P2 sample assessment paper. That in that one we have this number 4 where n square plus 2 is not divisible by 4. So this one is already, I have solved this in this exhaustion video. So you can check out the solution of this question from that video. I will be adding the link in the description box. You can, since they didn't even mention any specific range of values of x, range of values of n, no specific restriction or something. I have used from 1 to 10 in that solution video. But then again, you can also express this in terms of n as a 2k and n as 2k plus 1. Okay, so n, if n is 2k, n square plus 2 will be 2k whole square plus 2, which is 4k square plus 2. So this is actually the multiple of 4 plus 2. So adding plus 2 will not give us a multiple of 4. It has to be at a difference of 4, right? 4, right? So this is not this is not divisible by 4. Similarly, when you select n as odd, you can use this here. So n square plus 2. So 2k plus 1 whole square plus 2. So 4k square plus 4k plus 3. So this part is a multiple of 4, and then you have a plus 3 over here. It's 3 greater than multiple of 4, right? For 4, 8, 12, 16, the numbers are at a difference of 4. Adding plus 3 with any multiple of 4 won't result in a multiple of 4. It will give us a value in between these two, right? So this is also not a multiple of 4. That's what we had to prove. So in the solution video, you will see that I have used numerical values, but then again, you can also use this kind of variable thing using odd and even situation. That will also prove the problem, as in the expression is not divisible by 4. You can use this generalized situation, or you can even use the numerical ones. So that's the end of today's live session. So I have covered the past paper problems, and in my previous videos, you will get all the extra practice problems related to this proof of exhaustion, deduction, counter example, and proof by contradiction. But then again, if you think that you need to solve some extra problems, then you can go for the exercise problems from the P2 students book, chapter 1, P2 students book. You will get a lot of practice problems and example problems from that student book section. So you should solve those so that it's the concepts are a little bit clear. Since we have very limited papers, it's better to solve extra problems from students book. So we just covered the past paper problems from the proof chapter, proof topic. My next live session might be on AP and GP from P2, since you have your exam in like 25th, right? It's just 4 or 5 days. So keep practicing. We will see in the next video. Till then, take care. Bye-bye.